Greetings everyone, thanks for joining me. This is page 2 of the colligative properties practice, and this page deals with solutes dissolved in solutions that are not ionic, that are actually molecular. And one of the biggest rules about solubility is that like dissolves like. And so on the front page, all those ionic compounds are super polar. They're dissolved very easily by water, which is also very polar. But on this back side, we're dealing with molecular or covalent compounds, and so what's going to dissolve them well is going to be similar nonpolar solvents. So methane is a nonpolar solvent, and so like dissolves like, nonpolar dissolves polar, polar dissolves polar. So we're going to do this a little bit differently now that we have different solvents. Given in the problem, they give me the chart values I need for this Kb of methane, and this problem is just asking for the new boiling point. So the first thing we need to do is we need to figure out how much solution that we have dissolved, so our concentration. So we take our 75.0 grams, and we need to figure out what the molar mass is. And so I'm going to need to do a little addition here. I look at my formula, and we're just going to add up everything. 12.0 times 6, plus 1.0 times 12, plus 16.0 times 6, and we're going to get our 180.0 grams per mole for this solute. And so I'm going to go ahead and plug that in, and we're going to find that we have a total of 0.417 moles of solute dissolved. And so now I find the molality. I take that number of moles and I divide by the kilograms of solvent. So I look what my solvent is. It's methane. I have 500 grams, which again is 0.500 kilograms. And so my total molality then is 0.834, lowercase m, which is just moles per kilogram. The next thing I need to do is I need to figure out what my Van Hoff factor is. Because it's molecular, that means that this guy doesn't break up, C6H12O6. So my I for all molecular compounds is going to be 1. I is 1. Take out this parentheses here. And that is because it's molecular. So now what we need to do is we need to find the change or the new boiling point. So to find the new boiling point, we need this little delta Tb. So I'm going to find my change in temperature boiling. It's equal to Kb times m times I. And so now I need to look at, because it's not water, I need a new constant Kb for this solute, and there it is for methane, given in the problem there. So my change in temperature boiling is equal to 5.03 degrees Celsius over m times my molality, which I calculated before, 0.834, and my Van Hoff factor was 1, unitless. And so when I plug this in, molality, moles per kilogram cancel, leaving me with units of degrees Celsius, and so my change in temperature boiling ends up equaling 4.20 degrees Celsius. And so to find the overall boiling point of my solution, we take the original boiling point of my solvent, get my equation, but my solvent's not water anymore. Luckily, the problem gives me the boiling point of my solvent. Methane actually boils at 76.72 degrees Celsius. And so that's my original boiling point, and then we're going to add boiling point elevation, the 4.20 degrees Celsius that my solute caused, giving us a final boiling point of 80.92 degrees Celsius. It's going to be my final boiling point of my solution. So we have our boiling point elevation. No other tricks on here. The other thing I do want you to do is number 5. I wrote down the chart values wrong. I'd like you to add the negative sign on the Kf, the K freezing, and the negative sign on number 6 for the Kf as well, because the freezing point is decreased. So that needs to be a negative on there. Okay, this is all. I hope that this was helpful. Have fun.